Hello, my name is Pedro Morales. I'm a teaching professor at the Math Department at the University of California, Santa Cruz, and this is Math Talk. This week in our classes of linear algebra and precalculus, we touch very interesting ideas. But before going into that, let me just do a reflection about time management. I think that time management is very important, even more in this remote setting. We have to be more organized about the way we manage time. Scheduling some breaks, planning every day, and keeping up with deadlines are the three most important things about time management. With just following these simple rules, I think our schedules can be better organized and we can be more effective in our classes. So for the first class in linear algebra, this week we talked about very important concepts, something very geometric. We talked about the idea of generating a vector space with a basis, with a very important set of vectors. Whenever we talk about vector spaces, one way we can think about this is as the possible results of our linear combinations of a very particular set of vectors. Usually we call these vectors a basis for the vector space. Now, one very important characteristic about basis is that we can have different generating vectors. For example, if we think about colors, we can think about red, green, and blue as a generating set, but also red, blue, and yellow. So we can have different bases for the same vector space. But an important property is that no matter which basis we get, we always will have the same number of elements. This is what we call the dimension. Another geometric property we talked about this week was that of the dot product. We have addition and scalar multiplication with vectors, but we didn't have a multiplication between vectors. The inner product or dot product actually is an operation between vectors that will have a geometric meaning. For example, with this, we can define the idea of the angle between two vectors, and this is valid in any number of dimensions. That's why it's very important. It is closely related to the idea of correlation. So for example, in applications in machine learning or statistics, we have the correlation between variables as a very close relative to the dot product. Hence, the dot product carries a lot of information between the relation of vectors and also some very geometric meaning. In our class of precalculus, we actually talked about a generalization of the models we've been talking so far. I like to think about precalculus as a way of looking at different models in order to describe data. We started with linear models, which is one of the most simple models that we have. But then this week we talked about quadratic models and polynomials. The important thing about these higher order models is that we can include maxima and minima. That means a linear function usually does not give me a maximum value or a minimum value if we consider the entire domain. But whenever we consider a quadratic model, we actually are going to have a maximum or a minimum depending on the leading coefficient of this. The location of this extreme value is what we call the vertex of the parabola. So knowing the vertex gives me a lot of information about this quadratic model. But in some applications in real life, we can have actually both maxima and minima. We can have multiple maxima and multiple minima in the same problem. And quadratic models actually fall short with this. Hence, thinking about polynomial models is an improvement in the type of modeling that we can do, because we can incorporate these bends, ups and downs for describing our data. Also, another important thing about polynomials is the idea of zeros or roots, because by knowing the location of the zeros of a polynomial, we can actually compute an expression for this. This is a very important trick because we only need to have information of those zeros in order to have an expression that we can use. And these were the main ideas that we talked about in our class in this week. I hope this makes sense and that you stay tuned for upcoming episodes of this Math Talk. Goodbye.